Hello everyone, this is Vimal Singh and I am going to explain the inter-process communication uh, which is the one of the topic of the operating system. Let's start. Then what is the inter-process communication? Inter-process communication is the mechanism provided by the operating system that allow the process to communicate with each other to exchange the data or the something else. This communication could involve the process lettering another process is known as the same event occurring or transferring of data from the one process to another process. So it is called as a inter-process communication. Let's talk about the how many processes should be there. Processes can be two types: independent process and cooperating processes. So, what is independent processes? Which the processes which is not affected by execution of other processes is known as independent process, and the while the cooperating processes is that process which is affected by the execution of other processes. Means if we want to access the data from the other processes, then we have to wait so that that process can provide the data or so that we have to wait. Then it is a dependent it is a say we can say that it is a dependent on the other, so it is a cooperating processes. The processes can be communicate with each other with a from with through both properties, we can say shared memory and message passing. So we can explain one of them again and again. If you have any doubt, then you can ask me. Let us first discuss the what is shared memory. Let's suppose there is a process PA. PA is the process which want to share data with a B. Then PA is write their data in shared memory A, and PB is read the data from the shared memory. So PA transfer the data from the PB, then it is a communicating with each other. Means PA communicate with its B and B communicate with A. So it is a shared memory method. And let us talk about the what is the uh, message passing. So message passing method, in this the processes between processes communicate with a message passing. In this method, process communicate with each other without using any kind of shared memory. Means there is a no shared memory. If we take two processes, let's suppose P1 and P2 want to communicate with each other, they can uh, communicate with the help of kernel. Let's discuss with an example. If with a previous example, there is a process PA. Second diagram, there is a process A and there is a process B. If process A want to pass their message with a B, then it cannot directly pass their message with a PB. PB, huh? And then PA pass their message to the kernel, and kernel pass their message to the PB. Then PA not directly but communicate with the PB. So it is a communication, means message passing. With message passing, it communicate P1 communicate with P2, or we can say that PA communicate with PB. So let us discuss what is a critical problem. Critical problem is used to design a protocol followed by the group of processes, so that when one process has entered in critical section, no other processes is allowed to execute in its critical section. अगर एक प्रोसेसेस जो है एग्जीक्यूट होने के लिए इंटर हो गया क्रिटिकल सेक्शन में, तो अदर कोई प्रोसेस जो है वो क्रिटिकल सेक्शन में नहीं जा सकता, ये इसका रूल है. सो critical section refer to the segment of the code where the processes access shared resources such as common variable, file, perform write and read operations. Since it is also known as race condition. What is race condition? When two process access and manipulate the shared decisions concurrently एक साथ, and resulting execution outcome depend on the order in which the process access the resource is called race condition. Race condition lead the inconsistent systems of data. There we need a synchronization protocol that allow process to cooperate while manipulating or sharing data in a critical section problem. So we have to discuss the how we can solve this problem. So that solution of this problem is how what are the requirement to solve this problem. First is requirement is the mutual exclusive. What is a mutual exclusive? So let us discuss. When one process executing in a critical section, no other processes is allowed to execute in a critical section. First requirement is that progress. Second requirement is progress. When no processes is executing in its critical section and there exists a process that wishes to enter in a critical section, it should not have a way to independently to enter. So third condition, bounded waiting. There must be a bound on the number of times a processes is allowed to execute in a critical section after another processes has requested to enter its critical section. Before that, the requested is accepted. So there are the three requirements. We have to fulfill that requirement to solve the critical section problem. So most of the solution are based on the solution include test and set and compare and swap, lock and smap for condition variables. So let us discuss generalized architecture of the solution. Uh, so discuss test and set. Use a boolean variable lock and test and set instruction that executed automatically and set the passed parameter value to true. Okay, first solution is that, and second point is that compare and swap, same as test and set, except that passed parameter value in a set is true if it is equals to acceptance in the parameter to compare and swap instruction. So condition variable, let us discuss condition variable. Utilize a queue for a process that are waiting to enter in a critical section. हमें उस क्यू को यूटिलाइज करना है, रेडी क्यू को, वी कैन से दैट रेडी क्यू, जो कि जो प्रोसेसेस वेट कर रहा है इंटर करने के लिए क्रिटिकल सेक्शन में. सो यही है सॉल्यूशन फॉर द क्रिटिकल सेक्शन. So I think I have discussed all the points. So thank you for that. Let's end the topic.